there's only, when you're doing integration, there's only three inverse trig functions that you have to worry about. Arcsine, arctangent, arcsecant. You don't have to worry about arc cotangent, arc cosine, arc cosecant. Those don't exist, okay? So these are the only three you have to worry about. So what is arc? Arc is inverse, right? What does that mean? Well, it's just the opposite question, right? If I say sine of pi over 2, you look at your table and you say that's 1, right? Inverse just means flip the question. Instead of asking what is the ratio at that angle, you're asking, okay, when I have a ratio of 1, where is that going to exist? Pi over 2. So that's what that means. It's just the opposite question you're asking, okay? Instead of what's the ratio, you're asking what's the angle, okay? Okay, so these are one of the things that, when do you use these? The key is when U substitution doesn't work. It's one of those things that you have, okay? Okay, so so like number 1A. It looks like a problem that we've seen. It looks like a problem from your worksheet that you're doing, right? But can you guys see that U substitution won't work for that? Why won't U substitution work for this problem? What's the problem if I use U substitution? Can anyone see it? Picture it in your head. What would be the issue? Don't worry about the bounds. Don't worry about the bounds right now. Just worry about the function. Yeah, right? If I pick, what's most likely I'm going to pick for U? The bottom, right? 1 minus x squared. And then you find derivative of that, right? That's negative 2x. That's what I'm going to have to put back in. Well, that's going to have to cancel out with something. It's not going to. So this is where U substitution won't work. Okay, so when you're looking at problems where you're integrating, that's what my eyes always go to. It always goes to what's the bigger function, what's the littler function, will they cancel out? That's a quadratic. When I find the derivative, it's going to be linear. There's nothing linear else in there. 2 is just a constant. Okay, so that should kind of give you a key that U substitution will work. Okay, so we look at these relationships here. These three relationships here. Okay, which one does it match closest to? The first, second, or third one? The first one, right? The first one it matches up closer to. Why? Because it's got a square root at the bottom, but it doesn't have anything in front of the square root, right? There's no value in front. So this is the one that matches the best. So that's what we're going to use. So we're going to have an A and a U, and it's going to be arcsine. Okay? So we're going to rewrite it. First of all, I'm going to rewrite it. That 2 in front, I'm going to move it in front. So it's going to be 2 times the integral. So it becomes 1 minus x squared dx. Okay, so the 2 is meaningless. It's just it's gonna multiply at the end. Okay. Okay, so we said the first one, right? The first one is arcsine. So the first one has an A and a U. Has an A and a U, right? So let's define what A is and let's define what U is. So what value is A and what value is U going to be?
1 is A.
1 is U. Here you go, right? 1 is A and X is U. Not X squared because it already was squared over here, right? So it's going to be X. 1 squared, X squared, so the 1 and the X, okay? Well, just like we've done in the past, when you have your U, even though it's not traditional U substitution, anytime we get a U, that's why they use the letter U, you always find the derivative. The derivative is 1, right? So you divide by 1, and you get that, right? Okay. Now I'm going to move arcsine in. So it's kind of like substitution. So I have a 2. Instead of the integral, so in other words, you're integrating right now by substituting what it's equal to, or what it's equivalent to. So you have arc sine, parentheses. I'm not going to put the plus c because I have bounds. I have a 1 and a 1/2, right? Okay, in the parentheses is my u over my a. My u, we said, was x, and my a is 1, so it's just going to be x. So 2 times arc sine of x. Now I don't have to do antiderivative because I already did it. Converting it over to arc sine was the antiderivative part. So the last thing I'm going to do is plug in 1, plug in 1/2, subtract. Okay. All right, so here we go. So I get 2 times inverse sine or arc sine, however you want to say it, for 1, minus 2 times arc sine of 1/2. Okay. So what this is asking is, where on the unit circle am I going to get a ratio of 1 for sine? Pi over 2, right? We just said pi over 2. Right? So 1, we're going to put a 1 here, so this is equal to, pi over 2. Where am I going to get a ratio of 1/2 on my list of sine?
Pi over 6.
Pi over 6, right? Usually first quadrant. Usually just pick the stuff in the first quadrant. Don't worry about the stuff later on. Pi over 6.
What happens to the 2 in front?
So the 2 in the front's going to multiply, so it's still there. So we get 2 pi over 2, which is just pi. And then 2 pi over 6, which is pi over 3, right? So 1 whole, so 3, so in other words, it's 3 over 3 pi. 3 pi over 3 minus 1 pi over 3. What do you get? 2 pi over 3. Okay. All right. Again, B, if I tried to use U substitution, it wouldn't work. Because if I would make the bottom my 1 plus x squared, I'd make that my u. But again, it wouldn't work because if I find derivative, it's going to be 2x. And then if I plug 2x back in, it won't cancel out anything. You'll have u's and x's together. That's not what we want. Okay? So we go over to one of these guys. So this one's the easiest one to identify because it doesn't have a square root, right? So it's going to be the middle. It's going to be tangent. It's going to be arctan. So the first thing we got to do is figure out what's going to be my a and what's going to be my u. What's going to be my a and what's going to be my u. Okay? So a is going to be 1 again. U is going to be x. So du would be 1 dx. So it would be 1 du equals dx. So in other words, they're the same. Du is equal to dx. They're both exactly the same. Integrate. How do I integrate? Well, write it as it was up there. So it's 1 over a. So 1 over a is 1 over 1. Arctangent. U over a, so x over 1. We don't need to write a plus c for this one because we got bounds. The next two examples don't have bounds, so that one's going to need a plus c, but these don't because we have bounds. Okay. So I get arctangent pi over 3 minus arctangent of -1. So where is tangent pi over 3? Where's the first place tangent pi over 3? Usually we just look for the first place it's pi, or sorry, not pi over 3, square root of 3. Yeah. Is it pi over 3?
Yeah.
There you go.
Yeah.
Okay. Where's the first place that arc tangent, or sorry, where tangent is -1? 3 pi over 4?
Yeah.
There you go. Common denominator is going to be 12. So that means this is going to be 4/12, and this is going to be 3/12, or 9/12, sorry. 5, 12, 9, 12. You get -5 pi over 12.
What a fun problem. Hey, I see pound.
Okay. The only difference with C and D is that you don't have bounds. That's the only difference.
Well, CC of bounds.
He was balanced.
Does C have bounds?
Yeah.
No, sorry, change C.
No wonder.
No wonder.
There you go.
Yeah, you.
So 2 with bounds, 2 without bounds. Yeah, so erase C that was there. We don't have to worry about that one.
I
Do
don't
this
think
one.
I can erase it.
Okay. So again, if I tried to integrate this guy, it wouldn't work because I would do U substitution for this guy and it would give me 72x, and that wouldn't work because I would try to plug it back in and I would be stuck with an x. Okay? So first thing we always do, if this guy is not 1, make it 1. If this guy, let's say, this is a great question. What if this guy was x like that? What if this guy was...
Then you could use substitution.
Then I could use U substitution. Yeah, so then you would do it. You probably have a problem like that on your worksheet, okay? So that guy, don't worry about. If that's a function, you couldn't move it in front, but it would be U substitution would work, yeah. So this guy, we're gonna move to the front, -3. 1/9 plus 36x squared. Okay, so what is A and what is U going to be? So this one's going to be arctangent again, right? Because it doesn't have a square root. So what is A and what is U going to be? A is going to be 3. A is going to be 3 because it's 3 squared makes 9, right? And 6x squared makes 36x squared, right? So that means U is going to be 6x. So then du is not going to be 1. Du is going to be, that's going to come in handy next when we do that because that's going to move in. It hasn't mattered before because du has always just been 1, but it will this time.
Darn.
Okay. So I have -3 times arc tangent. Oops, sorry. Nope, I forgot the first part. There's a fraction in front. It's 1 over A. A is 3, so it's 1/3 times arctangent of U over A. U over A is 6x over 3, right? What is 6x over 3?
2x. No.
2x, yeah.
Okay.
And then here, I have 1/3 arctangent of 2x as well.
It's odd that it's minus
Oh, yeah, it is.
1.
Okay. So distribute your threes, your negative threes, your negative threes. Those are both going to make negative ones, right?
Yes.
Oh, sorry. Before I did that, wait, let me go back a little bit. Wait, why did I do that?
Maybe it's just the same problem.
I did it like there was bounds, but there is no bounds. I should have just done it once, yeah. I wrote it like there were bounds when there aren't bounds. So let me rewrite this. So we get 1/3, right?
Yes.
We had 1/3 before. We had a negative 3 in front. Then we had arc tangent of 2x, right? Now I have to substitute in dx, because there was a dx at the beginning. I didn't write dx here. I should have written dx just to keep it. But there was a dx at the beginning, so now I have to put in 1/6 du. So you have negative 3 times 1/3, which is negative 1, times 1/6, negative 1/6.
Correct me if I'm wrong.
Arc tangent 2x plus c.
Well, I'll be. We didn't even
Done.
get that.
You don't have to plug in anything because there's no bounds.
I wrote a completely different series. Oh my.
Okay, so look at D. Look at D real quick. Before we do, obviously it's going to be arc something because it's on this. I wouldn't put it on these notes if it wasn't. But look at it. If I pick x squared minus 4 as my u, isn't du in there? It looks like it, but it's really not. Why is it not? Why is that x really not x to the first power? Why is it not linear?
I don't know.
You can't split it.
No, we could split it. Yeah, you could split it.
No, you can split it.
Oh, yeah. It's
Because, yeah, if I move it to the top, it would become x to the negative 1, right? So it's really not linear. It's x to the negative 1. So even though it looks like, hey, that's an x, it's really not an x to the first. It's x to the negative 1. If it was up here, then it's x. So then you could do u substitution. That would be fine. But this x here is not what it seems, okay? So just be careful with that. So because of that, we have to use the one we haven't used yet, arc secant. Arc secant. Okay? So the negative 1 I'm going to move to the front. So we got negative 1, x square root x squared minus 4 dx. So it's arc secant. What is going to be my a term and what is going to be my u term?
A is 2.
A is 2 because 2 squared makes that 4. Good. What about u? X. So again, this one won't matter with the substitution, but it's good habit to do this so that you never forget to do it.
Please note that you did try to refer all the phase answers and really quickly move the.
Okay. So this one's arc secant. So arc secant starts 1 over a. 1 over a. So that's 1 over 2. Arc secant. And then it also has absolute value bars. U, sorry, just U. Just the top part has absolute value bars. The bottom doesn't. U is x. A was 2 plus c. So you get negative 1/2 arc secant. So I would leave those, but the only time you need them is when you're plugging in something that's negative. If you're plugging in something that's positive, You don't need those absolute value bars. But since we're not plugging in anything, just leave them. Just leave them there. It's just saying arc secant can't have a negative, can't be negative. That's all they're saying. Okay? All right, we'll finish the rest. The rest won't take that long either. Average value isn't, it's kind of what we've been doing. So average value we'll leave for Monday, okay? We'll leave that for Monday, and then, so I'll give you the weekend. So that gives you the long weekend just to finish up the practices that I've already had. I'm not gonna give you another practice. So all the practices that we've had so far, that's what I want you guys to work on for the rest of the weekend, okay? And then Monday, we'll finish and I'll give you the practice, or sorry, not Monday, Tuesday. I'll give you the practice for this guy.